Good afternoon from Europe, and please welcome Chune and Robert. So we're here in a series of different webinars trying to explain and demystify to our audience what is quantum networks, quantum communications, quantum internet, and today we go into space. And can you first start, Chune and Robert, telling us a little bit more about Spectral and especially the original idea? How did you guys meet? How do you guys get together? And where did the idea come from to start this amazing adventure?
Yeah, so we started Spectral has the roots in the Center for Quantum Technologies, based in Singapore. I was a student there a long time ago, and then subsequently, there's the third co-founder, it's called Professor Ling, who essentially followed through the project and the research to miniaturize quantum devices that can be put on a small satellite. So Rob here was a senior research fellow at the team. And essentially about 7-8 years back, we kind of got together and said, hey, this is a great idea, and let's go out and do space and quantum.
Yeah, pretty much. I was my background's in physics, then I went into space physics, but I ended up in Professor Alex Ling's group at the Center for Quantum Technologies, and I was the satellite team lead there for the SpooQy-1 mission. The SpooQy-1 mission was demonstrating a highly miniaturized light source that could demonstrate the principles of quantum entanglement, how particles of light could be correlated together in ways that is counterintuitive to common understanding. And this special behavior of light can be used to make encryption keys and to share random data that can be used as the basis of encryption keys in a highly secure way. And it was that technology and that capability that we saw the potential for commercial applications, and that became the nucleus around which Spectral could be built.
What makes Spectral different, and why is space needed in this field? Where does space come from?
So yeah, I mean, so space is required for global communications. So for local quantum communications, you can use optical fibers, and this will work over the scale of a few hundred kilometers perhaps. But if you want to scale this over intercontinental scales, then that's where satellites need to play a role. And yeah, if you want to send encryption keys over long distances, then you'll reach certain limits if you try and do this over optical fibers, particularly if those fibers are passing through other countries and areas where you can't have the same level of control over the hardware.
So what are the similarities? Back in the day, decades ago, communications started also on land and then moved into space. That's where the big satellite companies came in. What are the similarities with what's happening today in quantum communications?
Yeah, I think the evolution is very similar. With quantum key distribution, this is actually more pronounced because there's no way like an intercontinental subsea fiber would be able to carry quantum signals efficiently, right, without the use of very complex and yet to be discovered technologies. So satellite-based QKD today, as we see it, is probably the only way to do quantum communication at a global scale with current existing technology for the satellite and space, and as well as the quantum technologies we have today. So it's realizable, right now and within the next 1 or 2 years.
So maybe you can share with the audience how come Singapore is one of the leading countries in this field. How does it feel trying to connect the entire world from Singapore?
Yeah, Singapore is an interesting kind of cross between what our worldview is when we interact internationally and how we kind of organize the local economy as well as a little bit of a function of history where, the Center for Quantum Technologies has been set up 20 years ago when quantum was not hot at all. It wasn't even like, a commercializable domain. But for Singapore, in terms of the quantum safe connections or quantum safe deployment, we never operate in silos. We are very, very globally connected. We depend on the world for trade, for finance, and so on and so forth. So communication has always been very, very important. And the fact that we have a very safe ecosystem in Singapore, as well as a very robust telecommunication and cybersecurity infrastructure, enables global companies to set up shop here, MNCs to set up shop here, and really creating that security and safety and advanced innovative infrastructure, right? That is key to our long-term, quote unquote, economic well-being.
Singapore also has some advantages that we're a very small country, and one of the challenges with QKD is it only works over short distances, but that's not a problem here. So it's a very achievable goal that the government can set if they want to make Singapore a QKD secured place to do your business. That's entirely achievable here in ways that it isn't in every country.
Can you explain who are you connecting first? Who are those entities? Can it be government, probably Department of Defense, military, or financial institutions? Or do you see the demand from somewhere else that is willing to pay a premium or explore this new technology to protect the customer's information? Where do you see that demand coming from?
I think we see the market as actually quite distinct. There's a government defense sector and a commercial sector. But we do see there's a very strong interest from the government defense sector because they recognize the threat, and they have the information and data are very, very valuable, and they need to protect that. So a very strong kind of interest and demand there is moving forward quite fast. For the commercial sector, we do see a few major sectors that require this quantum safe technology earliest. I mentioned the banking sector is number one. It percolates the whole of the economy. The other sector, I think, the data center / cloud computing companies, where these are entities that handles data on behalf of their customers, and broadly kind of the telco world, which is also a partner for us usually, that are taking a strong interest in QKD, either to protect their own infrastructure or also to provide a solution for their end customer or user.
And what has been the evolution of the change in the industry since you started all this? What has changed in the field and across the different industries for you guys?
So I think back 10 years ago, that's when Chune and I first met, and it was at the IAC conference in Israel, International Astronautical Congress, and I was giving a couple of talks there, and I particularly remember the one I gave in the security session where I was explaining the concept of QKD, and I sort of almost laughed off the stage. There was someone in the audience there just saying, "Oh, this is nonsense. This will never happen. Just have fun with your physics experiments, but don't try and propose this as a security thing." And so we've moved on from that, thankfully.
Yeah, same here to echo. I think from the other angle is that 10 years ago, most of the work was R&D, and I think the R&D is continuing and stepping up for kind of pushing next generation technology. But at the same time, we are seeing budgets from governments, from the private sector being carved out for quantum safe and QKD technology. So there's a shift within the last 10 years. And I think that shift would continue to grow, even accelerate over the next few years, obviously with a lot of work being put on the quantum computing side, which enhances or the urgency of a quantum safe deployment and transition.
And you guys are working, I saw the recent announcement with Thales and other companies. Can you share a bit more about those kind of partnerships that you're doing How is that helping you, and who are the other partners that you're working with?
So with Thales, we're collaborating them on satellites. So we provide the satellite service, and they provide a ground station. So they have their own satellite QKD ambitions. They're developing their own entangled photon sources, plan to launch their own missions. We're a few years ahead of them in terms of our missions and our developments. So our satellites should launch first. Their ground stations they hope to have in place before their satellites, so that they can test their ground structure systems with our satellites.
Another recent collaboration you may have picked up is a collaboration with SES, is a satellite operator based in Luxembourg. They do have a quantum satellite going up called the EAGLE-1 satellite.
Mm-hmm.
And the whole idea, at least the genesis, was that we can deploy an optical ground station, a quantum optical ground station, that can interoperate with the SpeQutral's quantum satellite and also the EAGLE-1 quantum satellites. That would essentially, ease the burden from the user side, that you just have one optical ground station, let's say in Singapore, that can interoperate with both satellites. It adds resilience, redundancy, more choices for the end users, and so on and so forth. And there was also a recent one, the Hispasat, closer to Spain. Very exciting program. They're launching over there with a large consortium of company. There we are, trying to offer our technology and services for the quantum receiver on the ground side, and also testing with our quantum satellite. They will come online in the next year or so.
Do you do the entanglement on the ground and then send the entangled particles to the satellite? And are you looking to do the entanglement on the satellite in the future?
So we do the entanglement on the satellite.
On the satellite.
So we create the photon pairs on the satellite, and then send one of each pair down to the ground station and measure the other of each pair on board the satellite. Now, in the future, we hope to be able to have larger, more sophisticated satellites that can send both photons down to two different ground stations. And in such a configuration, you can share keys between two users on the ground and prove that the satellite has no knowledge of the key that's been sent to the ground. So this is really the gold standard in key distribution technology, because you don't even have to trust the satellite. If the users on the ground can run tests on the photons they receive, prove to themselves that they've received entangled photons, then they've just proved that no one else, including the satellite, can possibly know the keys that they've just derived.
Entanglement is my favorite fundamentals of all quantum physics. I think there is so much potential in it, and we just scratch the surface of how we're using it. Let's say you have a city major that says, I want to be part of that global communications infrastructure. How do I do it? What do you answer to them? And how much would it cost them? Is it just like, hey, put a ground station here and then you just have to connect it? What do they have to do?
First, I guess, I presume that the local, city would deploy this, on the fiber-based QKD. That's a necessary step, to get locally quantum secure. And then for satellite, if the city wants to connect to other cities around the world, then yes, then the ground quantum optical ground station is necessary. The next challenge is, what are you going to use it for? Who are you going to connect, and which is the other side that you want to connect to, right? So if a city, the mayor wants to do it, that's half the equation. There must be potentially another city with a equally motivated mayor that also wants to do it, and then you can connect the two, and then you can find the banks or whichever other industry that wants to be the first to pilot. Conceptually, it's easy, but realistically on the ground is a challenge to get just to align on the use cases. What goes first, and so on and so forth.
And we only have a few more minutes, but I'm curious about, how do you see SpeQtral growing and in the future, let's say 5 years from now or something like that?
The initial thought is, to do satellite-based QKD at a global scale. You need scale, pardon the pun. You need scale, right? You need to be able to solve it for 100 sites or 100, different locations within 50 cities, something like this.
Okay.
So not only the technology needs to be in place, but the ambition for the provider to scale must also be there to convince the users to come on board. It's a bit of a chicken and egg thing, right?
Yeah.
So we're talking about 5, 10, 15 satellites to start with. And you don't have to launch all 20 at one time. You launch, 2 or 3 at a time, and then you scale up as the demand grows. But to do this, then we are looking for strong partners that have the same vision, and kind of pulling the resources together. We are good at the quantum device, quantum payload. We have expertise in satellite engineering, space technology, but there's a lot of players out there that is only focused on space. So, I think the probably the interesting strategy over the next 5-year time frame is really to look for such partnership to scale like to a good network, good constellation.
Guys, we're finishing here. Any last message that you would like to share with the audience that we have not covered?
I think just to say that the QKD is where it starts, but it's not where it ends. So the end goal here is to build out the quantum internet to enable entanglement to be shared globally as a resource that can be used for secret keys for encryption, but can be used for much more than that. It's something that can be used for networking the future quantum computers, something that can be used for making quantum sensors even more sensitive, providing quantum devices with qubits and entanglement, and basically unlocking all sorts of technologies that we can barely imagine right now will be realized when a quantum internet is finally built.
Excellent. Well, thank you so much for taking the time. We'll continue the conversation in person, maybe in Singapore.
No worries. Yeah, happy to be
My
on.
pleasure.